Hey guys, it's me, Bud. Welcome to part 2 of our math video. I am so sorry we have not uploaded these videos sooner. I'm going to make these videos more frequent so that people like you, yourself, that have troubles with math, you can understand it much better because of me, moi. But either way, the reason why I didn't upload the videos before is because I actually made part 1 a long time ago. But I wanted to make part 2 so I could put them together because you probably would have been like, okay, where's part 2 coming out? So I wanted to upload them together so you guys could see what you do in like just part 1 and part 2 and watch them at this, not at the same time, but one after the other, just so it'd be easier for you guys. But either way, one thing came after another and I couldn't finish part 2 until now. I am so sorry, but right now we are focusing on math. We have to do this. And if I sound different, well, guess what? It's because I got a new microphone. Ba-da-da. Well, either way, let's go to perfect squares now, since we did difference of squares. I think that was what the other one was called. Either way, let's go with example 3, and we're expanding. You will notice that, hey Abdullah, this looks like it's in vertex form. You are correct. And let's go on, because we obviously see that if this is in vertex form, what are we going to do to make it into standard form? Well, you see, that is very easy. You see the exponent 2 over these variables and numbers? Well, this means that x minus 5 is being times by itself. So it's x minus 5 times x minus 5. So what we do x minus 5 times x minus 5 right here to make it easy. And then you FOIL. So it would be x times x times negative 5 times x, and negative 5 times negative 5. That's very simple. And then we would just simplify this down, and we would make negative 5x minus 5x, and that would give us x squared minus 10x, sorry, negative 10x. Oh wait, since I said minus, never mind. X squared minus 10x plus 25. And you'll notice from difference of squares, this, like the b, actually stays. In difference of squares, usually when you try to expand, you realize that there is usually no b. But in this case, since we're doing perfect squares, there is a b. And we'll find out why later on, even though it's quite obvious. Alright, this is our second question. And you're probably thinking, hey, don't we just do the exact same thing that we did up here? Correctamundo, my friend. You are 100% correct. I am happy you guys are learning. So we would just do 4x plus 5 times 4x plus 5, since it's in vertex form. And then we would just simplify this down, but, sorry, not simplify. We would do FOIL. Yeah, 4x times 4x times 5 to equal these numbers. And by now you're probably getting bored of me saying this times this times this times this. So I'll just like stop it or like slow it down because you guys already know what we're doing. So it would go to 16x squared. Remember, x times x equals x squared, and 4 times 4 equals 16. Plus 20x plus 20x plus 25. Then we just simplify this down and say 16x exponent 2 plus 40x, because 20x times, plus 20x equals 40x plus 25. So let's go to something a bit harder. In fact, let's go to example 4 where we actually have to do the opposite. Instead of expanding, we are factoring. So let's get our first number out here. And you're probably wondering, how do we go from expanding to factoring in perfect squares? Well, we have to do something called a check. What is a check, you may be asking? A check is, see if 2 with the it's basically to see if these two numbers a and c equal b when they are square rooted times 2. So we can see b equals 2 times the square root of a times the square root of c. So it's very simple to do. You have to, alright, if you guys have problems writing down equations like this, then just keep writing them down until it sticks into your head. That's usually what I do, and it usually turns out really well for me. So I recommend that you guys do the same. So you're probably wondering, does that mean I just put numbers in here? Well, yes. You would put 1 in A and 64 in C. And you're probably wondering, why do I put 1 in A? Shouldn't I put x squared? No. We only put numbers in here because the x's, and especially the x squares, will mess us all up. So we would put 1 because, well, this is obviously not x times 0, because every time we see an x here or x or to exponent something, we know that is always times by something. If it's just an x with the exponent, it means it is timesing by 1. We just don't show it because, well, do you really need to see a 1? I mean, come on, it's 1x squared. You don't really need to see that 1. So it's basically an invisible 1 because it's so shy, man. Just think of that. So just square root these numbers, and then we would come up with 2 times 1 times 8. Remember, you have to square root these, obviously. So then you would times these together. For me, this is what I usually do. Since it's 1 times 8, I would just take out the 1 entirely, and I would just say 2 times 8. But if your teacher wants to see the 1, then put the 1 in. And then you would get the exact number up here. And you're probably wondering, but Bud, there is no negative on this. Over here we have a negative. Relax. For this, to find the b, you don't have to find if it's a negative or a positive. It's the reason why is because when you're square rooting, you obviously can't find a negative, because if you put the if this was negative 64, you can't square root that. Put it into your calculators and try it out. Try squaring negative 64. It'll just say error or this will not work or something along those lines, because you cannot square root a negative number. So we always come up with this being positive only because we just can't square root negatives. Hope that was very simple for you to understand, by the way. But either way, as long as it's the same number here, like 16, it's fine. Now that we know that it's b equals 16, which it does, we have to put in the vertex, because obviously we're doing this when you're factoring in perfect squares. You have to put it in vertex form because that's the way how you do it. So before anything, I'm not going to explain this right now. I'm going to first show you the answer, then I'll explain it. You're probably wondering, where did you get these numbers, Bud? Well, it's very simple. I got the 1, so I got the x from here, and I got the 8 from here, and I got the negative from negative 16. That sounds simple enough? So here's what I'm going to say. Every time doing a vertex, like vertex form, you always know that it's x minus h, or whatever the teacher calls it for you. But either way, you know it's x minus something, or in this case, a number. So since it's x minus a number, and we know what x is, which in this case, x is 1. By the way, if x was 2, we would put 2x, just to represent this is a 2. And we'll go on, and I'll show you that later on as we go. But either way, we get the negative from the negative 16, so we just take the negative here and we put it down here because we don't like making our own negatives. And we get the 8 from here. And that's the reason why we have to put b equals these numbers, because if it doesn't, then you can't do it. And actually you can do it, but I'll show you that way in the end of this video. Now, let's try this one. this one might look quite hard to you, but believe me, it's the same thing. Like you just put these numbers in the check, which remember the check is b equals 2 square root of a square root of c. So we would just put 9 in here where the a is supposed to be, because obviously we put 1, which let me go back here so I can show you. We put a 1 here because it's x times 1. So we just put the 9 here because now we see that's x times 9. And then we put the 16 here because we see that c is 16. Now, let's see, does it actually equal to b? Well, let's just put the numbers down. We see that's 2 times 3 times 4. I like putting even numbers with even numbers, like 2 and 4, so that would equal 8. 8 times 3 is 24, and that's your answer. B equals 24. Alright, now try to come up with the vertex before I show you the answer. Did you come up with it yet? If you said it is 3x minus 4, because we have a minus here, and the 4 came from here, we just simply put this in. And don't forget to put the exponent 2 on the end of it. Let's go with something much more interesting. Let's see this. This looks very hard. Why can't we factor this, you may be asking? Well, like I said, you can't factor a negative number, because as we see, this is negative 16, so we can't factor that for obvious reasons, because, well, you can't square root a negative, and since it's a negative, we can't square root it. So that's the answer to that. So by the way, if you ever see this in a test, you know that your teacher is completely trolling you. So always say can't factor, and try putting the check in with the negative, and like say you cannot factor this because you cannot square root a negative, or something along those lines. Now let's go into this example. Alright, seems simple enough. I know what I have to do. I have to put in a check. So let's put in our check. Let's put our numbers in. Oh, this isn't looking good so far. Let's put them anyways. Oh no. Oh no, 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 no. B equals 20. And remember, x times 1, so we put a 1 here, and 100 right here, and 2, because we have to put this by 2. But so far, this isn't looking good. It says b equals 20. Obviously, we know it's trolling. And by that, I mean, well, we know that you can't factor this. Or can we? We can actually factor it using another method. Remember when I said a is the an m, and how m is multiplication, a is addition? Well, we just find a number that can go to 100, and that can go to negative 52. Since we know it's a positive and this is a negative, we know that they're two negative numbers. So a number that can go into 100 is 50 times 2. Oh wait, 50 plus negative 50 minus 2, or plus negative 2, equals 52. So it's x minus 2, x minus 50. So, as you can see here, this is in factored form. And you might be recognizing, didn't we do this in the other question? Yes, we did. But remember, if you can't find the vertex of it, try to find the factored, if your teacher tells you to. If she just tells you to find the vertex, just try to find the vertex. But since you know the zeros in this, you can also find the vertex using these zeros. Now let's quickly do this. As we can see, we have a common term, which is 4, so we would do 4 bracket x squared, because every time we have a common term, we have to do this. And then we would just do the numbers inside. So let's do the check. And knowing this, we would have 2 times 1 times 3, which will equal 6. And that would equal 4. Remember, the 4 comes from here, because we can't get rid of this 4. X minus 3 squared. So what did we learn? Well, we learned that we need 3 terms, and the middle term must be an even number. And the reason why it must be is because when you add, because look at the second, look at b equals 2. If we have 57, like if these two numbers times to each other equals 57 times 2, it will always be an even number. So thus the middle number always has to be an even number. Both the first and the last terms are perfect squares, because if they are not, it will not work. Remember, a perfect square is like 1 times 1 equals 1, 2 times 2 equals 4, 3 times 3 equals 9, and so on and so on. And the check must work. If it doesn't, you have to find another way how to find the vertex. And by the way, I just want to go back here and show you something. Oh, lag, I think. I don't know what's happening. Oh no, technical difficulties. Ah, here it is. Just had to do this. Oh, whoops, I went 2 back. Yes, this is so professional, people. Okay. Alright, I didn't explain the 4 here properly. The 4 has to be here, because if you're trying to put this back into standard form, the 4 must be here, because then you're going to put 4 times x minus 3 times x minus 3. And remember the way how I taught you guys how to put something back in from factored form into, because this still is kind of like factored form, and you basically have to put it in the same way. So remember the way how I showed you up here before? You have to do it the same way with the 4. Or with any number that you get. Because the terms that were, how do I explain this? The common terms, you have to put the 4 here, divide everything by 4, and then you put the 4 here, because the 4 cannot disappear, because if it does, if you don't put the 4 here, the answer will be wrong, and your teacher will give you probably a 0 if she's or he is a bad teacher, or just a really hard one, or you will get very few marks, or you'll just miss 1 mark. So remember, this putting in the 4 always matters. So look here, and then put it in here at the beginning though, then put in the rest of the numbers in here in the brackets. Either way, that concludes my video. Have a wonderful day, a wonderful everything. See you guys.